Absolute value day 2, focus on inequalities of absolutes. Notice in a graphical representation that your disjunction occurs above the line for this particular example, and your conjunction occurs below the line in this particular example. In example number 2, we'll identify where the disjunction and the conjunction is relative to the horizontal line y equals 2. So it is a conjunction when the absolute value is below the horizontal line, so that is going to be less than 2. It is a disjunction when the absolute value is above the horizontal line y equals 2. That will be greater than. Using logic for question number 3, an absolute value can never be less than a negative number, so an absolute value is always greater than a negative number. Using graphical representation, you'll see that this holds true. The answer to this is all real solutions, and this one is does not exist, or undefined, or no solutions. Steps for solving absolute value inequalities algebraically have been written in already. Step 1, isolate the absolute value. Step 2, identify disjunction or conjunction by using the catchphrase greater than, greater, or less than. And please remember from the notes above, the absolute value is on the left side. Write the two inequalities. Please pay particular attention to switch the symbol for the negative solution. Solve for x and write the solution set. Alright, here we go. Step 1 is to isolate, so we get 3 plus 2x greater than or equal to 13. Add 4 to both sides. Now we will identify this as greater, so this is going to be a disjunction. Step number 3, write the two separate inequalities. 3 plus 2x greater than equal to 13. 3 plus 2x less than or equal to negative 13. Step number 4, solving for x. Subtract 3 to both sides. 2x greater than or equal to 10. 2x less than or equal to negative 16. Divide out the 2. And we get x greater than or equal to 5. X less than or equal to negative 8. Solved. Question number 6. Now we're getting into the process of multiple numbers on the same side. So remember, when we're isolating a variable, we always solve PEMDAS from the bottom to the top. This means that the 5 moves first, not the 4. And I get 4 times the absolute value of x less than or equal to 2. Divide by 4. The absolute value of x less than or equal to 1/2. Absolute value of x greater than or equal to negative 1/2. 2 solutions. Okay, so the answer to this problem, oops, I did not identify that, less than, so that's less than, and we're going to do negative 1/2 is less than or equal to x, which is less than or equal to 1/2. If you wanted to leave it like this, we would simply put the AND statement between them. Alright, the 3 needs to be moved to the other side. Remember, it's division. Multiply both sides by 3, and I get 2x plus 7 less than or equal to 3. That is less than, so again we're going to have another AND situation here, and we're going to do 2x plus 7 greater than or equal to negative 3. Solving for x, we'll subtract the 7 first. 2x less than or equal to negative 4, 2x greater than or equal to negative 10. Divide by 2. X less than or equal to negative 2. X greater than or equal to negative 5. So, again, leaving it like this, insert your and, but more appropriately, start with your negative 5 less than or equal to x less than or equal to negative 2.